internet capabilities right now. Okay, so we do just have a few days left, and the factor theorem is really important. So we're going to try to get through factor theorem, and I'd like to also get in behavior because it's pretty easy. And then if we got to the other stuff, that would just sort of be yay. But those two things for sure I'd like to get through. Okay? For sure. All right, so we've got equations of functions here. And we have them in factored form, and then we have them in standard form. And they've given us the graph. Okay, so factored form, standard form, graph. And we're going to identify the zeros from the graph, then synthetically divide the standard form by each factor. We're not going to do all of these because I think you're going to kind of get the point after the first one. So I have a 0 at -2. I have a 0 at, oops, I skipped one, -1. And I have a 0 at 1. So I have 3 zeros right there. Then we're going to do synthetic division of each factor. I feel like at this point, we kind of realize how those factors and those zeros relate to each other, right? If I have a factor of x plus 2, that means I have a 0 at x equals -2. If I have a 0 at x equals -2, that means I have a factor at x plus 2. You know how they're like opposite sides of each other, right? Okay. Now, if these are truly zeros and I divide by x plus 2, what's the remainder going to be? 0, right. If they're actually truly factors, the remainder is going to be 0. So we'll just do this first one real quick. Let's see, I'm going to divide by -2. 1, 2, -1, -2. And looky there. Ta-da. Okay. So we kind of already knew this was going to happen. We don't really have to take the time to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 synthetic division problems. I think we can fill this out down here. What's the relationship? What's the connection between zeros and a factor and the remainders? The zeros tell us the factor. The factors. And also the factors tell us the zeros, right? I can switch that around. And then what happens when you use synthetic division? If you use synthetic division with a factor, what's the remainder?
0.
Yes.
What does that say? If you use
Synthetic division with a factor, the remainder is 0. And we can turn that one around too. If the remainder is 0 in synthetic division, then you found a factor. I'll let you get that written down, and then that's going to lead us to the actual factor theorem, which is at the top of the next page. You just flip it over. Did everybody get that whole punch? Didn't go over there. Randy, will you pass it to that table back there?
Oh, fine, that's it.
All right. So complete this statement. If x equals a is a 0 of the function, then the factor x minus a is a factor of f of x. And when f of x is divided by this factor of x equals a, the remainder is 0. Yes. Okay. Is 2x plus 1 a factor of g of x? Show and explain your work. What's the graphical interpretation of the result of this work? If I need to know if it's a factor, I have to divide and see if the remainder is 0. If I divide and the remainder is 0, yes, it's a factor. If I divide and the remainder is not 0, no, it's not a factor. Okay? So I'm going to go over here. 2x plus 1 equals 0. 2x equals a negative 1. X equals a negative 1/2. So in my little half of a square right there, I'm going to put in a negative 1/2. And then what's going to go here? 2. 3.
Negative 11.
Yep.
Negative 6.
Yes, you just take your coefficients listed in descending order. Bless you. On the quiz yesterday, not a lot of people messed up their synthetic division. Some people messed up multiplication, which kills me. I let this class use a calculator. And some of you still messed up your times tables. So I'm going to bring that 2 straight down. Negative 1/2 times 2 is a negative 1. When I add 3 plus negative 1, I get 2. Negative 1/2 times 2 is a negative 1 again. And negative 11 plus negative 1 is a negative 12. Negative 1/2 times negative 12 is a positive 6. And the answer on that is 0. Okay, so factor. 2x plus 1 is a factor because the remainder is 0. What's the graphical interpretation of that? So what does that mean as far as the graph goes? What is happening when x equals negative 1/2? Nope. When x equals negative 1/2, what happened over here when x was negative 2? It touches. Yes. That means if this is 0, that means when x equals negative 1/2, the graph touches the x-axis. Remember factors and zeros. Remember how they're related. And a 0 is where it touches the x-axis. All right, try this one on your own. You're going to put a negative 2 right here. 2, negative 1, 3, negative 8. And tell me if x plus 2 is a factor of f of x.
No.
Why not? All right, when you work this out, you get a remainder of negative 34, right? Okay, so no, x plus 2 is not a factor because the remainder is not 0. And right now, what does it mean graphically? It means it's not going to touch the x-axis at x equals negative 2. When x equals negative 2, the graph will not touch the x-axis. Got it? Okay, now divide, this is f of x cubed minus 13x plus 12. Notice they skipped x squared, so you have to put a 0 in. So we're going to put 0, and we need to divide by x minus 3 and then factor the quotient. So I'm going to put a 3 right here, and I'm going to have to write small because it's not really a lot of space. 1, 0, negative 13, 12, 1, 3, 3, 9, negative 4, negative 12, 0. Okay, so I know it's a factor, right? Do you remember how to write this answer? Because we haven't written the answers again in a long time. What would that answer be?
All of it.
X squared. X squared plus 3x minus 4.
0.
You don't have to put 0 over x minus 3 because it's 0 cancels out. You don't have to do that. You can just leave it like that. Okay, then it says factor the quotient. So I have to factor what's left there. What are two numbers that will multiply to give me a negative 4 but add to give me a positive 3? What? Negative 1 and 4. Okay. Now B, divide the same one by x minus 1. So I'm going to put a 1 right here and then factor the quotient. 1, 0, negative 13, 12. 1, 1, 1, 1, negative 12, negative 12, 0. I'm left with x squared plus x minus 12. What are two numbers that multiply to equal a negative 12 but add to be a positive 1? Bless you.
Positive 4 and negative 3.
Yes, x plus 4, x minus 3. Divide by x plus 4, then factor. So I'm going to put a negative 4 right here. 1, 0, negative 13, 12. You think it's going to be a factor? Yeah, I think it is. I feel it because like I've already seen x plus 4 2 times here. I feel like it's going to be a factor. 1, negative 4, negative 4, positive 16,
Yeah, it's a factor.
3. Spoiler alert. It's a factor. X squared minus 4x plus 3. Hey, what are two things that multiply to give me a positive 3 but add to give me a negative 4? Here's a hint. You've already seen them.
What did you say?
Multiplies to give me a positive 3 but adds to give me a negative 4.
X minus 1 and x plus 2.
About minus 1 and minus 3 because I need to be a positive 3. Okay, so this has a cube, which means it has 3 zeros. What are the 3 zeros for f of x?
X minus 1.
Ooh, you're giving me factors.
X plus 1.
Yep, x equals +1. X equals what? Somebody else said one. -4. And what's the last one? Yep. Those are my 3 zeros. And I know this because I divided by that and it worked. Okay. Let's look at page 499. Okay, so this is telling me that if x minus 1 is a factor of this, then what are the other two factors? Okay, so first of all, I just want you to divide. If you get a question like this, you're going to divide this into that. That's the factor. So go ahead and do the synthetic division without me, and then I'll join you. If I feel like it. All right, so you got that. You got that it has a remainder of 0, so we know it's a factor, which they told us it's a factor. So, okay, I get it. And then my new function is that. That's my depressed polynomial. And then it says, what are the other two factors? Okay, if I have to find out what the other two factors are, I have to factor this. So this needs to be factored, either tic-tac-toe or X factor or bottoms up or whatever it is, your preferred factoring method. So I got a 2x minus 3 and an x plus 1. I used X factor. No, I didn't. Just kidding. I used tic-tac-toe. And then it says rewrite g of x in completely factored form. There you go. We're going to skip 6. We're going to look at number 7. Number 7 says, for what value of k is the factor x minus 2 a factor of the function p of x? And then you notice p of x has a k in it. All right, we've actually done these problems before, but he explicitly told you what the remainder was going to be. This time he just says, what does k have to be in order for it to be a factor? Well, in order for it to be a factor, what does the remainder have to be? 0. So you know how to do this problem. You already know how to do it. You do your synthetic division, you set it up. Now, some of you had a little bit of trouble with the distributive property on the quiz for the k problem. So I want you to go ahead and do 7. And then we'll kind of work it together. But I want you to go ahead and start out on 7. And then we'll do it all together. All together now. Make sure you watch when you're supposed to be distributing versus when you just have to multiply. Okay, so the 6 comes straight down, right? 2 times 6 is 12. Negative 19 plus 12 is negative 7. 2 times negative 7 is negative 14. And then right here, you come up with k minus 14 because you can't combine those. They're not like terms. When it goes from here to here, that 2 has to be multiplied times everything. That's 2k minus 28. Because 2 times k is 2. Negative 14 times 2. 2 times k is 2k. 2 times negative 14 is negative 28. Then when you add, these two are still like terms. So you're basically adding 6 plus a negative 28, which gives you that negative 22. So tell me one more time, what does 2k minus 22 have to equal? 0. And it has to equal 0 because we want that to be a factor. And if it's a factor, the remainder is 0. So you have 2k equals 22. K is 11. Perfect. Number 9, it says, is x plus 1 a factor of f of x? And if so, how many times is it a factor? This one, you're just going to keep dividing the answers by x plus 1 until you don't get a remainder of 0 anymore. So let me show you how you know how to do the math. I just want to show you how to actually write it on your paper. So you write everything out. 4, 3, 2. Okay. So negative 7, negative 3, positive 3, positive 2, negative 3, positive 3, negative 4, positive 4, 1, negative 1, 2, negative 2, 0. So it's a factor that time, right? Now you can save yourself some space because you're just trying to see how many times it goes into it again. You can just put another little box right there and just carry on your synthetic division from right there. You don't have to rewrite the problem all over again. So that's going to be, you're going to bring down the negative 3, and that's a positive 3. Negative 1, positive 1, 2, negative 2, 0. So that's a factor. And let's try it again. So I'm just going to put like a negative 1 right here. You don't have to rewrite it every single time. Negative 3, positive 3, 2, negative 2, 0. That's a factor. I'm going to rewrite it because it's in that pre-AP thing's in the way now. Bring down my negative 3. That's positive. That's 5. Is it a factor that time? No. How come? The remainder's not 0, so it's not a factor. So how many times did I get a remainder of 0? 3. So it's a factor 3 times. It is a factor 3 times. It said how many times? 1, 2, 3. I got 3 zeros over here. So today is really just a lot of synthetic division, which you already know how to do, and talking about remainders being 0. It's not really new stuff. It's just a different way to look at stuff you've already known. Oh, like that? How many of you are in a push? Okay. All right. I think so, in this class.
Jackson was. Oh, Jackson's too.
He's gone anyway, so yeah.
Truck.
Still, like you just walked away? Like you just walked away from it?
There's no time to do.
I had a car once I just walked away from. Like I got what I needed out of it and walked away. I don't know what happened to it. Yeah, it was a horrible piece of crap car. Oh, all right.
I can't even, we can't even move it at all. Why don't everybody pick it up?
Okay, so before I stop the recording, let me say what the homework for today is. The homework for today is day 61's homework. Day 61, which it's 11 problems. And again, it's a lot of zeros and remainders and synthetic division. So you've got, for problems 1 through 4, use synthetic division to determine if it's a factor, and then write yes or no. If it's a factor, how will you know? The remainder is going to be 0. Exactly. And if the remainder is not 0, it's not a factor. Okay. And look, we just answered number 5. Okay. Number 6, it says here are the only factors. How many times is each a factor? That's just like number 9 that we did. Same as 7. Number 8 is like number 9. Number 8, 6, 7, and 8 are like number 9 on the homework. Let me say that because that kind of sounds confusing. Number 9 asks you to use a graphing calculator to draw this graph. If you don't have a graphing calculator, you can use Desmos on your Chromebook. That's my favorite website in the whole wide world. Here's a K problem and a K problem. So there you go. That's your homework. 11 problems, just a bunch of synthetic division. Because we love synthetic division. Way better than long division. All right. And this.
So if we're going for a question on, have it done for whenever we come back.
Yes.
I think that day's Wednesday.
Oh.